Ừ. साउंड कोड का बता ना लोड आपका पापा ने कासा को से ना दिला उसको ಇಲ್ಲ ಆಮೇಲೆ ಸರಿ
Hello.
Hello.
Hi, good morning, guys. Can you hear me?
Yes, sir. I am principal.
Yeah, hi, sir. How are you?
Very fine, sir.
Yes, tell me, guys. Yeah. Yes, sir. Please tell me. So I will be taking chemistry, sir. We'll start chemistry.
Yes, sir. Yes, sir. I had seen yesterday.
Yeah.
Waiting for participants actually. If 21 are there total.
Yeah, we'll
Sir,
have.
I think we can start. They add one by one.
Yeah. Should we wait for 1 or 2 minutes, or should we start, sir?
Sir, we can start. It is 8:30. No, time is given.
Yeah. Okay. Okay, guys. So I hope the screen is visible, right?
yes sir. Yes sir.
Okay. Guys, like as you know, we are going to start. Chemistry, 12th grade chemistry, right? So,
Yes.
so tell me, like, there's classes are going on in your college, chemistry classes, or it will start after this? No, the lockdown get over after that. See, in 12th grade chemistry, I hope as you all know this thing, that the majority of the portion, 12th grade chemistry, if you see, the majority of the portion is organic chemistry, right? Almost 60-70% organic chemistry we have, okay? So this is very important for your exam also, 12th grade exam also, okay? So today what we'll do, we'll start some basics, concepts of organic chemistry, which helps you actually in the entire organic chemistry of 12th grade. Okay, and we study all these topics under this thing. The topic name will write it as general organic chemistry. General organic chemistry. Okay. So just I'll ask 2-3 things. Have you heard about inductive effect? Guys, have you heard about it? Inductive effect?
Yes, sir.
Okay. The one very important thing here is resonance. Have you heard about resonance?
Yes, sir. Yes, sir.
Okay. Just a second. Okay. So inductive effect, you have resonance, then the other effect is hyperconjugation. Have you heard about it?
Yes, sir. Yes, sir.
Okay. And one more we have, that is electromeric effect. Okay, so what are these 4 different things that I have written here? What we call these as? These are various electronic effects. Okay, all these 4 are various electronic effects. What are electronic effects? These are the effects by which the transfer of electron is possible within the molecule. Within the molecule, right? So the first 3 effects here, these are permanent effect. And this, the last one is, it is a temporary effect. Temporary effect. Okay. The last one is not that important. Okay, but these 3 things are very important for organic chemistry. Okay, you will have the application of these things, especially resonance is the most important one out of the 3. Okay, so we'll discuss what is inductive effect, what is resonance, what is hyperconjugation today. Okay, these 3 things we'll try to understand why we are doing this, because this is, like I said, useful for all the other different chapters that you have in organic chemistry. Okay, so understanding of this is very important. Now, anyone, could you tell me what is an inductive effect? How do you define an inductive effect?
Polarization is caused by the adjacent sigma bonds.
What? Come again? Polarization.
Polarization is caused by the adjacent sigma bonds.
Okay, polarization caused by the adjacent sigma bonds. Okay, yeah, right. Right. So this means what? Suppose we have a molecule, say CH3, CH2, 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 Cl. This is the molecule we have. So these are electronic effects, inductive, resonance, and hyperconjugation. Means by all these effects, there is transfer of electron, right, within the molecule. So how the transfer of electron takes place in this molecule, that is inductive effect. Okay. Now you see the chlorine atom here is more electronegative. Yes or no? Any doubt in this?
No, sir.
Chlorine is more electronegative. Now, since the chlorine is more electronegative, it will drag or attract the bond pair of electron towards its side. Means these two electrons will be slightly shifted towards the more electronegative atom, right? And hence this atom becomes delta negative. So this atom becomes delta positive. Okay. And this becomes again delta, delta positive, and so on. It goes away from the more electronegative atom. Okay. So the point I'm trying to make is what? These two electrons are slightly shifted towards the chlorine atom. So this becomes delta positive, electron deficient slightly because of the positive charge on this carbon atom. So this positive charge will also drag these two electrons towards this side. And in order to this carbon has delta delta positive charge. So this positive charge density decreases as we go away from the electronegative element. Right. So this kind of shifting, it is a partial shifting of electron. This kind of shifting is known as again electronic shift, and the type of the effect we have, that is inductive effect. Is it clear?
Yes, sir.
So what happens here? First, the 2-3 properties are very important, and this question they ask in the exam: the difference between inductive effect and resonance. What is the difference we have? So 3-4 properties of inductive effect we'll see here. Then you will understand what is the difference we have between the two. Okay. So the first thing here you see in electronic effect, inductive effect, the more electronegative atom drags the bond pair of electron towards. Okay, it attracts the bond pair of electron towards its side. Okay. So what happens here that you see, if you have electron pair here, so this electron pair is slightly shifted towards the chlorine atom. The shifting is not complete, means complete shift. What I'll tell you here, if these two bond pair of electron jumps onto this chlorine, this is complete shift. Means the orbital we have here between these two atoms, electrons comes out of that orbital and goes onto the more electronegative element. So that leads to the complete shift and dissociation of this sigma bond. Leads to carbocation here and negative charge on chlorine atom. But this complete shift is not there. The bond pair of electron will be present in the orbital of these two, and it will be slightly shifted towards the chlorine atom. Right? It won't be here at the center of these two atoms, but it will be shifted towards the more electronegative. This shift is inductive effect. Okay. The first property of inductive effect is what? It involves, write down the properties, guys. It involves only sigma electrons. Sigma electron means what? The electron present in sigma bond. That is sigma electrons. Okay. So write down.
Oh. Oh. ಈಗ ಶುರು ಮಾಡಿದ್ರು.
Yeah, hello. Are you getting this, all of you?
Yes, sir.
Okay. The first property of inductive effect is what? It involves sigma electron. Okay. Second property, it is distance dependent effect. It is distance dependent effect. As the distance increases, inductive effect decreases. Okay, as the distance increases, inductive effect decreases. Okay, next one. It is a permanent effect. It is a permanent effect. Next point. It is the reason of dipole moment. What is dipole moment? You know this? What is dipole moment, guys? See, when two opposite charges placed at a very small distance, then that works as a dipole because we have two opposite pole into this. Okay. So because of this charge separation, this works as a dipole. And because of that only we have dipole moment in this molecule. And dipole moment is denoted by mu, is a vector quantity. Mu is equals to the charge q into distance d. And this distance we count from positive charge to negative charge. Means the direction of dipole moment is from positive to negative. Okay. Next point to write down. It involves only partial shifting of electrons. It involves only partial shifting of electrons. And hence, partial negative and positive charge develops on the atom. And hence, partial negative and positive charge develops on atom. Okay. So guys, do you understand whatever I said now in the inductive effect? You can type your response here in the chat box. If you understood this, you can type clear C and R in the chat box. Quickly, guys, fine. Yeah, thank you, Pranav. I got your response. Nihal, Yashwini, Sahana, Chitra, Mohit, Namrita, Sudarshan, Smriti, Madiha. Okay. Pooja, Kavana, right? Kavana. Kushi, Maulya, Wilson, Varshini, Tejaswini, Krushi, Ashwarya. Okay. Fine. So this is inductive effect. Okay. Partial shifting of electron. Now you see the another thing which is very important here, that inductive effect are of two types basically. Right? There are two types of inductive effect. That is plus I and minus I effect. Plus I and minus I. Even if you talk about resonance also we have two types. Plus R and minus R. Hyperconjugation, again we have two types, plus H and minus H. All these electronic effects are of two types, plus and minus. Correct? Fine. So plus means what? It is electron releasing effect. Right. Plus means electron releasing always. Whether it is plus R or plus M, all these are electron releasing. We'll discuss hyperconjugation also. Minus I is electron withdrawing effect. Electron withdrawing. So all those electron releasing group, ERG stands for electron releasing group. EWG stands for electron withdrawing group. Right? So what all electron releasing group we have and what all electron withdrawing group. Like we have plus I, minus I. Similarly, we have plus R and minus R in resonance. Plus H and minus H in hyperconjugation. Okay. Plus always means electron releasing. Minus always means electron withdrawing. Whether it is minus I, minus R, minus H. What is the difference between this resonance and inductive effect and hyperconjugation in resonance? We'll discuss that after this. Okay. So what all groups we have which shows plus I effect? First question is that. Okay. Now, two examples I'll write down here to make you understand. Okay. Suppose the first one is CS3, CH2, CH2, CH3. And the second one is CS3, CH2. Okay. Inductive effect is all because of electronegativity difference. Okay. Now you see the difference in these two molecules is what? Could you tell me the difference in these two molecules?
Chlorine atom is not present in the first molecule.
What?
Electronegative molecule is not present in first organic compound.
Correct. The first compound you see, all carbon atoms are sp3 hybridized and there is no electronegativity. You know what is hybridization?
Yes, sir.
How do we find out hybridization? You know that?
Yes, sir.
What is the hybridization of H2 molecule? Anyone?
sp2.
Yes.
sp3.
sp2.
DsP2. sp3. Okay, one response I'm getting sp3. Others, tell me. Hybridization of H2O.
sp3.
Achha, sp3. What is the hybridization of NH3?
sp3.
sp3.
What is the hybridization of XeF2?
sp3.
XeF2? What is the hybridization of CO2?
sp3.
sp3.
What is the hybridization of CH4?
sp3.
sp3.
You are getting sp3. What about the right? Is it sp3 CO2?
Yes, sir. sp3
You
itself.
can type yes or no also, others.
Sir, CO2 is sp3 itself.
Okay. XEF2 guys.
Hmm?
XEF2. Okay, I think we need to discuss this also, hybridization. To explain, how do you get, could you explain? I want you to respond in this, guys, please. How do you know, or how do we get the hybridization of CO2 is sp3? Okay, Yashashwini got sp, hybridization of CO2. Achha, tell me one thing. How do you know the hybridization of H2O is sp3? Could you explain this? Aishwarya, which one is sp3d? XCF2. Okay. Okay. How do you know that H2O is sp3? Could you explain? No. Okay. Okay, I got one more response. CO2 is sp2. Okay. Okay, let's just quickly discuss this, how to find out hybridization. And I can assure you, after this discussion, you will never forget how to find out hybridization. See, actually, I'm just deviating from this topic, inductive effect, but 2-3 minutes, then we'll again go back to that. Okay, you want me to discuss hybridization now?
Yes,
Because
sir.
it is a portion of 11th grade. Okay, but I think it is useful in 12th grade also, so you should know this. Okay, so quickly, 5-10 minutes, I'll take this also, hybridization also. So you see, for hybridization, what we do, understand this carefully, it's very important, guys. For hybridization, what we do, I'll give you a trick to find out hybridization. We'll find out steric number. Steric number. And steric number is equals to the number of bond pair plus the number of lone pair. Right? Number of bond pair, we also write it as number of outer atoms sometimes. Number of outer atoms. Okay. Now, according to the steric number, we'll find out in this thing, hybridization. So if steric number is 2, hybridization is sp. Steric number is 3, hybridization is sp2. Steric number is 4, hybridization is what?
SP3. SP3.
5,
SP3D.
6,
SP3D2.
and 7, sp3. Okay. The point is, once you know the steric number, you can find out hybridization. Okay. And to find out steric number, you should know the number of bond pair and the number of lone pair. So now the next question is, how do we find out the number of lone pair and the number of bond pair? So for this, what you'll do, you just calculate this thing. I'll just write down here. You just calculate this. Okay. So what I'll do, suppose you have any molecule given, and I'll take an example of just one example I'll take is suppose we have F2. This you need to find out the hybridization. So what I'll do, I'll just calculate the number of valence electron for this molecule. What is the number of valence electron? Could you tell me? Number of valence electron means what?
8.
Only 8. See, the number of valence electron is the electron present in the outermost
shell.
So xenon outermost shell has 8 electrons, and fluorine outermost shell has 7 electrons.
7 electrons.
So what it becomes? 22 electrons in the valence shell. Now what I do next, will divide this valence electron by 8. You'll get some quotient and you'll get some remainder here. Okay, this quotient gives you the number of bond pairs, and this remainder gives you the number of what?
Lone pair.
No, it's not lone pair. Number of electrons in lone pair. So from this information, could you tell me how many number of lone pairs we have? Is equals to? It's R by 2. Suppose 4 you are getting here. So 4 electrons are present in lone pair. The number of lone pair is R by 2. So what is the steric number?
2.
The steric number is Q plus R by 2, correct?
Yes, sir.
So this is what you need to calculate, and according to this value, you'll get the hybridization of the molecule. So for XeF2, you see, we'll divide this 22 by 8. So you'll get 2 bond pair and 3 lone pair. Yes or no? You find out the number of bond pair and lone pair. Is it right? Just cross check. Yes, I'm waiting for your response, guys. Is this correct?
Yes, sir.
So what is the steric number then?
5.
What is the hybridization then?
sp3d.
P3D.
Is the hybridization. Okay. Similarly, you can find out hybridization for, like I said, for CO2 you can find out. You can find out for XeF4, tell me this value. You can find out for XeOF2. You can find out for SF6. You can find out for NH3. You can find out for H2O, CH4, all this. Tell me this one by one. Try this. Let me know, guys, once you're done. Done? Okay, did you understand this?
Sir.
Okay, so all of you done?
Yes, sir.
Okay. So just let's start discussing this first. So what is the number of valence electron for CO2? Tell me.
18.
We have 4 for carbon and 6 for oxygen, right? So we have 16. So this 16 divided by 8 means what? We have 2 bond pair and 0 lone pair. So steric number is 2, hybridization is sp. Any doubt in this?
No, sir.
XCF4, valence electron is 8 electron for xenon, 7 for fluorine, so it is 36. 36 divided by 8, so we'll have 4 bond pair and 2 lone pair. Steric number is 6, hybridization is sp3d2. Clear? Okay. XeO2F2, valence electron is 8 plus 6 plus 7 into 2, 28. This 28 divided by 8, we have 3 bond pair and 2 lone pair. Steric number is 5, sp3d. SF6, sulfur, belongs to the same group, oxygen family. So valence electron is 6 plus 7 into 6. Okay, 48. 48 divided by 8, we have 6 bond pair and 0 lone pair. Steric number is 6. Hybridization is sp3d2. All these 4 questions, you got it? Understood, all of you? Please type in clear CLR if you understood this. Yeah, please type in, guys, quickly. Yeah, if you respond, it will be better for me to explain things properly. Okay, understood. Right. Now you see next thing. NH3, could you find out NH3 like this? Yeah, Nihal, any doubt? Okay. See, if you find out NH3, what are you getting? Number of valence electron? 8, 5 plus 3. So now what we'll do here, this is a different way here. When hydrogen is the outer atom, we'll divide number of valence electron by 2, not by 8. So here we'll divide by 2 because hydrogen is the outer atom and hydrogen can have maximum of 2 electrons. It shows duplet, not octet, right? So 2 by 8 by 2, we have 4 bond pair and 0 lone pair. It means steric number is 4, hybridization is sp3. For H2O also, if you find, the valence electron is 4 for carbon, 6 for oxygen, and 2 for hydrogen, it is 8. So again, 8 divided by 2. But since we have only 2 outer atom here, so we are getting here this number as 4. So out of 4, since we have only 2 outer atom, oh, I'm sorry, I made a mistake here. This should be, there should be 4 here first. I'll write down. This should be 4. And out of 4, we have 3 bond pair and 1 lone pair. Why 3 and 1 we have? Because the outer atom is only 3. That is the way how we do this. Outer atom is only 3. So we can have maximum 3 bond pair only possible. So out of 4, we have 3 bond pair and rest is the lone pair 1. 3 plus 1 is steric number is 4, hybridization is sp3. Similarly, here what happens, we got here 4. Outer atom is 2 only. So out of 4, we have 2 bond pair and rest is the lone pair. But again, the steric number is 4. Hybridization is sp3. CH4, the number of valence electron is 8. Again, if you calculate here, so 8 divided by 2 is 4. So out of 4, we have 4 bond pair because 4 outer atoms and 0 lone pair. So again, you see steric number is 4. Hybridization is sp3. So did you understand this point? How to calculate hybridization and all?
Yes, sir.
I want you to respond, guys.
Yes, sir.
Yes, sir.
Yes, sir.
All of you, please, fast.
Yes, sir.
Yes, sir.
Okay. So this is the way to find out hybridization. Okay. If hydrogen is the outer atom, remember we'll divide this by 2. If hydrogen is not, then by 8 and this. Okay. We have one more method. If you know to find out, if you know the structure, then also you can find out the hybridization. For example, like I told you CO2, correct? CO2, the structure is O double bond C double bond O. And for hybridization, or simply if I write down the steric number, if you know the structure, you can write down steric number directly. So for structure, the steric number is the number of sigma bond plus number of lone pair on central atom, because hybridization is defined for only central atom. Like if I ask you, what is the hybridization of CO2? It means we are asking hybridization of carbon only in this molecule for central atom. So number of sigma bond and lone pair if it is present, we can find out. So how many sigma bond we have here? Again, you tell me. How many sigma bond?
2
We have 1 sigma and 1 pi. 1 sigma and 1 pi. So we have 2 sigma bond and there is no lone pair, zero lone pair. You see the steric number is 2 from here, and hence hybridization is sp. Similarly, suppose if you have CH4, so the structure of CH4 is this. So we have only 4 sigma bond. Hybridization is sp3. If you talk about NH3, NH3 nitrogen has 3 bond pair and 1 lone pair on this. So we have 3 sigma bond plus 1 lone pair. So steric number is 4. Hybridization is sp3 again. If you have H2O, H2O is this. We have 2 bond pair and 2 lone pair. Steric number is 4. Hybridization is sp3. The point is, once when we know the structure, we can again find out the hybridization by counting number of bond pair and lone pair. Clear? Okay. Hybrid orbital does not form a pi bond. That's why pi bond we do not count into this. One last example I would like to show you, and how to find out hybridization in organic molecule. Suppose you have one molecule, say CH3, CH2, C triple bond C, CH double bond CH, then CH2, and then it is attached to
Benzene.
6-member ring, not benzene, 6-member ring. Here we have, I am drawing some random structure, okay? So it is CH2 again, and then CH3. What I want you to do, I want you to tell me the hybridization of each carbon atom here. What is the hybridization of this? What is the hybridization of this? What is the hybridization of this? This, for each carbon atom. Okay. What is this value here?
sp3.
It is sp3. Why? Because we have 4 sigma bond. What about this?
sp3.
What about this?
sp.
This one?
SP.
This one?
SP2.
sp2.
This one?
SP2.
sp2.
This one?
SP3.
sp3.
3 sigma, and 1 hydrogen is also present here. sp3. This one?
SP3.
This one?
SP2.
This one?
SP2.
sp3.
sp3
sp3.
Okay. Point is, once the structure is given, or if you know the structure of the molecule, you can write down hybridization by counting only sigma bond and lone pair. H2SO4. Could you tell me the hybridization of sulfur in this?
ನೀರು ಕುಡಿ
What? So for this, we know the structure of H2SO4. S double bond O, double bond O, OH and OH. And there is no lone pair present on the sulfur atom. right? So we have 4 sigma bond, 1, 2, 3, 4. Hybridization is sp2. I guess all of you understood how to find out hybridization. Okay. Yeah.
Excellent.
So now we'll come in. We are going back to this thing, I effect, and we were discussing about this, right? So here you see inductive effect is causes because of the difference in electronegativity. Okay. In this molecule, you see all the, and one more thing I forgot to tell you. You know the electronegativity order is this: sp hybridized carbon is most electronegative, then sp2, and then sp3. You know this?
Yes, sir.
Yes, sir.
Right? As percentage S character increases, electronegativity increases. Okay. So here you see all the carbon atoms are sp3 hybridized. So there is no electronegativity difference. Here this chlorine is more electronegative. So this will drag electron toward this side, delta negative and delta positive. And if you look at the difference in this structure and this structure, this part is same in both the molecule. Only the difference is CH3 and Cl we have here. So alkyl group has electron releasing tendency. It is electron releasing effect, all alkyl group. This is electron withdrawing effect. So this effect here of CH2, we can say it is plus I effect, and here it is minus I effect. Got it? Plus I and minus I. Plus I is electron releasing. All alkyl group shows plus I effect. Okay? Minus I is possible when the atom is more electronegative than the carbon atom with which it is attached. Okay? So two effects like I have already told you, plus I and minus I. You write down first plus I effect, what all molecules we have which shows plus I effect. All alkyl group shows plus I nature. Larger the alkyl group, more will be the plus I nature. More plus I effect. Like if I ask you to compare the plus I nature of CH3, then plus I nature of CH2CH3, and then plus I nature of CH2CH3. Which one has maximum plus I effect?
CH3.
Maximum is for the group which is large, this one. Order of plus I is this. Clear, guys? Minus I group, you see. One order I'm giving you. This order you should know, not all, but yes, little bit idea you should have. Which one shows maximum plus I or minus I or minimum minus I? NF3 plus shows maximum minus I effect. Then we have NR3 plus. F3 plus. NO2. CN. H. C double bond OH. Then we have fluorine, bromine, iodine, C double bond OR, OR, OH. Then we have alkyne. Then we have phenyl, the benzene ring. And in the last, we have alkene, hydrogen. This is the order of minus I2. Copy this down. Let me know once you finish this. You know what this order is all about? What do you understand by this order? Yes.
No, sir.
Done.
Yes, sir.
What this order is all about? This order is order of minus I effect. Means we can say NF3 plus shows maximum minus I. Okay. Few comparison you can do based on the logic. Like you see fluorine, chlorine, bromine and iodine. Which one is the most electronegative atom?
Fluorine.
Fluorine. So hence the minus I effect of fluorine is maximum out of the 4. Okay. If you compare this, logically also you can do. If I ask you to compare minus I nature of C double bond OCl and C double bond OH, which one shows more minus I?
C double O C L.
C double bond O.
C L.
Why Cl?
It is electronegative.
It is more electronegative than this carbon. Overall, the effect of this is more. Yes.
Yes, sir.
Okay. So like this, logically also you can compare, but I would suggest this order is important. This you already know. Okay, and these are the maximum one. These 2-3 things you should know. The entire series you don't have to memorize. Right? Now this I effect actually affects the stability of carbocation also. One of the application is this. That is the stability of carbocation. What is a carbocation?
Carbon containing positive.
Positive charge. So it is a carbon atom which has 3 bond pair and 1 vacant orbital. This is sp2 hybridized, X, Y, and Z. 1 vacant orbital here. That is carbocation, right? So stability of carbocation is directly proportional to plus I and inversely proportional to minus I. This is the order we have. Only 1-2 example we'll see. Okay. Of PUC, it's not that to that great extent they won't ask. Okay. See, what you have to memorize here, that neutral molecule is always more stable than the charged one. Okay. Neutral molecule is always more stable than the charged one. So by any means, if you are going towards neutrality, means the stability is increasing. Is it clear? Yes.
Yes, sir.
By any means, if you are going towards neutrality, the stability is increasing. So suppose you have one positive charge, carbocation, right? So this carbocation will get stabilized by plus I effect or minus I effect?
Plus I.
Why plus I? Because plus I is electron releasing. You are releasing electron and hence the positive charge gets neutralized because the electron is negatively charged. So because of plus I nature, you releases electron that will neutralize the positive charge and hence the stability is increased. If minus I effect is there, that will withdraw electron. So the positive charge density increases there, destabilize the carbocation. Understood? That's why the order is this. In fact, we can say the stability of carbocation is directly proportional to all electron releasing and inversely proportional to all electron withdrawing effect. Okay. For example, suppose if I ask you which one is the most stable carbocation here, we have first of all methyl carbocation, then we have CH2, CH3 carbocation, then we have CH, CH3, CH3 carbocation, and the last one is CCH3, CH3, CH3 carbocation. Could you tell me the stability order?
Increasing.
Increasing, left to right, okay? Why? Because you see here, CH3 has plus I nature, electron releasing effect. 2 electron releasing group we have, and 3 electron releasing group we have, right? So where we have the maximum neutralization?
Tertiary carbocation.
Tertiary carbocation, right? Here we have 3 plus I, so maximum neutralization is here. So this one is more stable than this and then this. Another thing, when the positive charge carbocation attached with only one alkyl group, it is 1 degree carbocation. When attached with 2 alkyl group, it is 2 degree carbocation. And when 3 alkyl group, it is 3 degree carbocation. Right? And that's why we say that tertiary is the most stable one. Any doubt?
No, sir.
All of you understood this?
Yes,
This
sir.
Yes, sir.
Yeah. Okay. Now the next thing we have to discuss is resonance. By the way, what is the first chapter we have to start with? What is the first chapter in your this thing, books?
Solid state.
What? What is the first chapter?
Solid state.
Solid state. They have started this chapter in the college, like you are taking online classes now?
No, sir.
Tell me, guys. Okay, fine. There's no online classes going on. Fine. So the first chapter we have to start solid state. Fine. So we'll start that once we finish this resonance and hyperconjugation. Probably from the next class we'll start solid state if you want, or if you want to start some organic stuff, that also we can start. Anyways, we'll finish these two things today only. Next chapter, whatever we'll say, we'll start with that. Okay. So what is the resonance? You know resonance?
Yes, sir.
What is the resonance?
Polarity produced in a molecule by the interaction of two pi bonds
In the presence of attacking agent.
I didn't get you. Again, come again.
Polarity
Polarity produced in a molecule by the interaction of two pi bonds or a between pi bond and lone pair of electrons.
Okay, lone pair and this. Fine. I think you memorize this actually. What is the condition of resonance? Suppose I'll give you two examples here. If I write down this, in which one resonance is possible? In which one resonance is possible? You know this?
First case.
First case.
Yes, sir.
Okay. Why in first case? Why not in the second case? See, if you know this, you can tell me. Otherwise, you can ask me to explain. I'll explain that. See, I'll tell you. See, resonance is what? First of all, the answer for this question is, in this one, the resonance possible. In this one, the resonance is not possible. Okay? Why? I'll come to this one. For this reason, you have to understand few things first. Okay? So what is resonance? You write down here 2-3 points. It is the resonance, write down. It is the delocalization of pi electrons or lone pairs. It is the delocalization of pi electrons or lone pairs. Next line. It is the method of representation of
It is the method of
representation of one molecule or ion into more than one structural unit. I will explain you this. First, you write it down. Into more than one structural unit in which the position of pi electrons and lone pairs are different. Okay? Position of pi electrons and lone pairs are different. So first thing you have to observe, like I said, you must know the difference between resonance and inductive effect. The first thing is, in resonance, lone pair and pi bonds are involved. Pi electrons are involved. Sigma electron does not involve in this. Write down. Sigma electron does not participate in resonance. In resonance, it only involves pi electrons or lone pairs. That is the first difference. Next one, write down. Unlike inductive effect, it is distance independent effect. It does not depend upon distance. Comparison and properties I am giving you all this. Okay. Distance independent effect. Next one, position of atom is fixed in resonance. Position of atom is fixed, it does not change. Next point, position of sigma bond is fixed. Yes. Next one. The pi bonds and lone pairs are interconvertible. I'll explain all these points by example, but you write down first all the important properties. Pi bonds and lone pairs are interconvertible. The next one, the very important one, the various structural unit we draw in which the position of pi electrons and lone pair is different. Pi electrons and lone pair is different is called resonating structures. Resonating structures. So what you write resonating structure here, and we'll use this term very frequently in this topic, resonating structure. So you write down the short form of this also. Resonating structure, we write it as RS. Okay, so in bracket, you write down RS like this. All these structural units are called resonating structure or canonical structure. Have you heard this name? Canonical structure? Yes or no? Or contributors. Also, all these three things are same. Resonating structure, canonical structure, or contributors. Okay? These structures, all these structures are imaginary structure. These are hypothetical or imaginary structure. Imaginary structure and it does not explain all the properties of the molecule or ion.
All the properties
Of the molecule or ion. Okay, does not explain all the properties of the molecule or ion. Next thing, did you write this point? It is distance independent effect.
Yes, sir.
It does not depend upon distance,
Yes, sir.
right? Okay. Now you see a few examples here to understand resonance. Suppose if I write down this one, CS3 C double bond O, O minus, and this one, CS3 C,
कैसा होना?
sorry, you see these two structure. These two structure are the resonance structure actually. RS, resonance structure. How do we draw resonance structure? This oxygen has 3 lone pair. So one lone pair comes over here, forms a pi bond, and this pi bond shift over here and give you this. Okay, you see what happens. Lone pair converts into bond pair, and bond pair converts into lone pair. That's why we say the position of pi electrons and lone pair is different, right? Or lone pair and pi electrons are interconvertible, right? So all these structures are resonating structures. You know what is this structure? What is the name of this molecule? What is this?
Benzene.
Benzene. And what is this?
Benzene.
Both are same structure?
Yes, sir.
Both are different structure here. When you number the carbon atom, you see this 1, 2, 3, 5, 6. And when you number the carbon atom 1, 2, 3, 4, 5, 6. You see here between first and second carbon, we have here double bond. First and second carbon will have here single bond. So these are the resonating structure. Okay, where the position of pi bond is different. Understood this point?
Yes, sir. Yes, sir.
Have you seen this structure? See, something like this. Have you seen? Yes. Have you seen this?
Sir.
What is this structure?
Benzene.
Benzene.
Benzene. So what is the difference?
It's showing resonance.
What is the difference between these two?
The resonance is not showed in this. Mirror.
Position of double bond.
Position of double bond. Okay, so I got a response. They have finished haloalkanes and haloarenes. Okay, fine. We'll do that, Ashwarya. Okay, no worry, we'll do that. So some basic understanding of organic you must have, and then we'll start that. Yeah. What is the difference in this structure and these two structures? Anyone? See, actually, this structure is the real structure. Real structure means once you take, whenever you take benzene, you'll get this only. And this we call it as real resonance hybrid. The real structure is resonance hybrid. Okay, and in short, we write it as RH, resonance hybrid. So actual molecule is this. This is the resonating structure of this benzene. This is the resonating structure of this benzene. All these resonating structures are not real structures. These are imaginary structure. These are the structure that we draw, imaginary. This is also imaginary. We draw this structure. But when you take benzene molecule, it will be in this form. This, what do you mean by this circle here? This circle means that these pi electrons are delocalized over the ring. It is continuously moving like this. Okay, so that is the real structure. These are the resonating structures. Okay, if you draw the real structure here, these are the resonating structure. The real structure of this one will be this. Pi electron delocalized from this oxygen to this oxygen. So that will be something like this. This represents the delocalization of pi electron. This is delta negative, this is delta negative. So this is the real hybrid RH. You are RS of this real hybrid. Got it? Understood this?
Yes, sir.
Any doubt, guys? Tell me. No doubt? Okay. So these are the resonance and resonating structure I have explained you. Okay. Now, how do we know by looking at the molecule that the resonance is possible or not? Are you getting it? You should have the idea then in which molecule the resonance is possible. So basically, what is the condition of resonance? Right? So the condition of resonance is the molecule or ion must be planar and conjugated. Planar and conjugated. What is a conjugated system? You know that? What is a conjugated system?
Closed.
Closed. No, it's not. See, there are mainly 5, 6 types of conjugated system we have. Okay. And this conjugated system you should know, then only you can say if the conjugation is there, then resonance possible. Right? Conjugation is very important for resonance. Without conjugation, resonance is not possible. So I can explain you the reason behind this also, why conjugation is required and all. But that thing, you have to understand a lot of things into that. Okay. Which generally we teach students for IIT, JEE and other exams. Then we'll discuss all those stuffs. Okay. But conjugated systems are what? So write down here. What are conjugated systems? See, if you have alternate pi bond, the system is said to be conjugated. Okay. So we'll see that if you have pi sigma vacant orbital, it is a conjugated system. I'll show you one example of all these. Okay, pi sigma vacant orbital conjugated system. If you have pi sigma and lone pair, it is also a conjugated system. Okay. Then if you have pi sigma free radical, okay, I'm just giving you this. What is important for you, I'll tell you. Okay, pi sigma free radical, one single electron it is. It is a conjugated system. Right, then we have pi sigma pi. conjugated system. Okay, alternate pi bond. Then if you have pi sigma vacant D, pi sigma vacant D is again a conjugated system, vacant d orbital. This is d orbital. Okay, vacant d is a conjugated system. And the sixth one, the last one we have, is this, the lone pair sigma and vacant d is also a conjugated system. All these 6 type of conjugated system we have. Okay, so mostly for you, the important one is this. Means mainly with these, you can have this. We can have this, we can have this, and this. These 3 are the most, easier one, and most frequently we'll use these 3 types of conjugated system. Okay. Now, what is pi sigma and vacant p orbital? So, if you have this, one example we'll see for all these. The first type of conjugated system is pi sigma vacant p orbital. So, this is the CH2 double bond CH, single bond CH2, positive charge on it. So, positive charge on carbon atom, it means it has one vacant orbital here. Positive charge on carbon atom is possible when we have a vacant p orbital like this. Then we have the positive charge. You see pi sigma vacant p, so it is a conjugated system. So when you draw the resonating structure of this, and the resonating structure is separated by this double-headed arrow, this arrow. So this pi electron shift over here, and we get CH2, single bond CH, double bond CH2, and here we have the positive charge. Since this carbon atom loses its electron, this carbon will have the positive charge. So this is the resonating structure. Did you understand this?
Yes, sir.
Basically, when you have pi sigma and vacant p like this, the system is said to be conjugated, and when the system is conjugated, resonance is possible. Okay. Similarly, the second example we'll see for pi sigma pi. Only important one I am discussing, okay, which you will get in the exams. CH2 double bond CH, single bond CH, double bond CH2. This also is a conjugated system, and the resonating structure you can draw like this. It comes over here and goes onto this carbon atom. So it will be CH2 single bond CH, double bond CH, single bond CH2. Since this pi electron shift onto this carbon, it has one negative charge. This carbon electron loses this bond pair of electron and positive charge. Did you understand this? Let me know if you have any doubt. So this kind of system, we call it as conjugated system. And in conjugated system, resonance is possible. Okay. So the condition for resonance, the system must be planar and conjugated. Okay. Planar means within the same plane. Conjugated means these 6 types of conjugation should be there. Okay. What is resonance? Resonance is a hypothetical concept where the lone pair and sigma bonds are lone pair and pi bonds are interconvertible. Okay, lone pairs and pi bonds are interconvertible. It is distance independent, but the other one, like inductive effect, is distance dependent effect. Understood this? Now this resonance effect also have 2 types, plus R and minus R. Just a second. Plus R and minus R. Plus R is electron releasing again, ERG, and minus R is electron withdrawing, EWG. Examples of plus R I'll write down here. We have OH, We have NH2, OCH3. We have NR2, etc. Electron withdrawing is, we have C double bond OH, electron withdrawing, C double bond Cl, electron withdrawing, C triple bond N, electron withdrawing, C double bond O, OR, electron withdrawing. All these are electron releasing and electron withdrawing effect resonance. Okay, there are many things. There's a lot of things you have to you can discuss over here, but I am not going into all those things. Okay, because those things are not required for your PUC exams and other exams. Okay, but basic understanding you must have. One simple comparison I'll tell you here. How do you know that the group is electron releasing group or electron withdrawing group? Shows plus R or minus R. How do you have this information? Okay, so the plus R effect is possible when the first atom which is attached to the ring contains at least one lone pair. You see, oxygen has 2 lone pair, nitrogen has 1 lone pair, 2 lone pair, 1 lone pair. So when at least 1 lone pair is present, the group is said to be electron releasing group. When there is a pi bond between the first and second atom, at least 1 pi bond, then it is electron withdrawing group. C double bond O, C double bond O, triple bond N, double bond O. All these are electron withdrawing. You know what is ortho-para group? Ortho-para effect, meta effect. You know this? Is it given in your textbook?
Yes, sir.
Ortho-para effect. Just one example we'll see. We'll see what happens with electron releasing group and electron withdrawing. It is important. Okay, in aromatic chemistry, you'll see when you get ortho substituted product and when you get para substituted product. That understanding you'll have from this particular example. Suppose we have OH present here. This is one molecule I am taking, and another molecule is this. We have here NO2, N double bond O. I did not write this NO2 here, but NO2 also, since we have double bond between the first and second atom, so NO2 is also an example of electron withdrawing group. Why it is electron withdrawing or electron releasing, you can understand with this example. And what is the effect of plus R and minus R effect, minus R group on the benzene ring, that we are going to discuss here. So OH has 2 lone pair on this. Why hydroxy group? Guys, listen to me carefully, okay, all of you. It's important, very important, okay? Listen to me carefully. Why hydroxy group is the electron releasing group? Because this, you see, pi sigma lone pair, conjugation is there. I have given you the conjugated system, you see this. Pi sigma lone pair, this one you see, pi sigma lone pair, a conjugated system, yes or no? Yes. Second time. Are you there, guys? Please respond.
Yes.
Right?
Yes, sir.
Second type of conjugation is there. Here also you see pi sigma lone pair conjugation is there. It means resonance is possible here. Okay? Here you see pi sigma pi. So again the conjugation is there. Resonance is possible here. Fine. This is one thing. Now, this lone pair, since oxygen has lone pair on it, this lone pair will convert into bond pair, and this pi electron converts into lone pair. So like this, we get the first resonating structure, and that will be this. These 2 pi bond will be as it is. Here we get the negative charge. Here we get double bond OH, and since oxygen loses its electron pair, it becomes positive charge. You always keep that in mind, that the molecule, original molecule, if it is neutral, then all RS will be neutral only. So you'll get one negative charge, so you must get one positive charge also. So plus minus gives you 0. Now the next thing in this, what happens? Yes, Darshita, any doubt? I can't hear you. After this, when you draw the resonating structure, you see pi sigma lone pair here. So this comes over here and this comes over here. Okay, fine, Darshita. So the resonating structure here is, we get a double bond here, we get a single bond here, one negative charge, and double bond OH positive charge on it. Next, again we can draw resonating structure, because again the system is conjugated, pi sigma lone pair. This comes over here, this comes over here. So this will be this. And the last structure we can draw is this. And that will be, this comes over here and this comes over here. This is the 5 structure we can draw. Okay. Anyone has any doubt in this, how to draw this resonating structure? Why this shifting of electron is taking place like this? Because the system is conjugated. If it is not conjugated, this kind of shifting is not possible. Okay. So now the conclusion that we can draw, obviously OH, like I have told you already, OH shows plus R effect, right? Plus R effect or plus M effect also we call it as. Plus R is resonance, plus M stands for mesomeric effect. And resonance effect, mesomeric effect are same thing, just two different names we have, but it is exactly same. Similarly, we have minus M also possible, negative mesomeric effect, okay, equals to minus R effect. See, again, important thing is, due to plus M effect or plus R effect, the electron density at ortho and para position increases. Yes or no? You know what is ortho and para position?
Yes, sir.
Yeah. So what happens, write down this, because of plus M effect, the electron density, because of plus M effect, the electron density increases at ortho and para position. Okay. You know what is an electrophile?
Yes, sir.
It is an electron deficient species, correct?
Yes, sir.
So now you see, if you have benzene ring OH attached onto it and any electrophile is present, E plus, then this E plus will have the tendency to join at which position? Ortho or para or meta? See, this E plus is looking for electron rich side, and because of this OH present on this ring, ortho and para position becomes electron rich. You see this negative charge? And hence this electrophile has high tendency to get attached onto the ortho and para position. And hence we get ortho para substituted product. Am I clear? Did you understand this? Did you understand this?
Yes.
All of you guys, please reply. It's an online session, okay? So if you do not
Yes,
reply,
sir.
I will be able to understand whether you are getting it or not. Okay? So in presence of an electron releasing group, like we have OH here, the ortho and para position becomes electron rich, and hence if any electrophile is there, this electrophile will attach at ortho and para position, and we get ortho para substituted product. Okay, so this is the understanding you should have in aromatic chemistry when you see the reaction of aromatic compounds. Okay, the reverse thing will be true if you have any electron withdrawing group present, like this. You see electron withdrawing group is there. So what happens here, this double bond O withdraws electron, right? So this pi electron comes over here, and this pi electron goes onto this oxygen atom. So the structure here we can draw is, we have double bond N, single bond O negative, one coordinate bond. Here we have the positive charge, double bond, double bond. Is it clear? Okay. Further, we can draw this as pi bond here, double bond N, O negative, positive charge here. And further, we can draw this like positive charge here, double bond, double bond, double bond, N, O negative, O. And the last structure is this. Double bond, double bond, double bond, N, double bond, O. How do we draw this structure? This goes over here, we'll get a positive charge. This comes over here, we'll get a positive charge. This comes over here, and this comes over here, we'll get this structure. So 5 structures again possible here. So what is the effect of this? At ortho and para position, what happens? Now to understand this, what happens at ortho and para position? The electron density, what? The electron density decreases here. You see positive and positive charge you are getting. Yes. Any doubt you have till here? Kushi, are you there? Kushi? Varshini?
No, sir.
Any doubt, Kushi?
No, sir.
Okay. Yashaswini, any doubt? I can see Darshan is there. Darshan? Okay. Hari Kiran is there. Karthik, are you there, Karthik? Okay, fine. Yes, Darshan, fine. So guys, have you ever been in this kind of online session, online classes? Or this is your first time, like the first time with this sentence thing? Did you take online classes earlier?
No, sir.
This
No,
is the first
sir.
time, right? Okay, okay, yeah, that's why I can understand that, because it's not physical classes. No, I can't see you. You can't see me. So it's very important to to interact. The class, the communication should be from both sides. Then only I can understand what doubt you have and what kind of confusion you have, and accordingly I can handle things. So both way communication is very important in online session. Please understand that. Yeah, I know that, Pranav. Before Centum, you do not have any online session. No? That's what I meant to be. Yeah, so online session, what happens? You should interact with your teachers. It is equally true for physical classes also. But in physical classes, it is easier to to build that connection, since the teachers and students are in front of each other, right? So that's the thing. So it's very important to interact. Why I am discussing all these, you see, maybe you haven't done all these things before. Have you done these things before? Yeah. Have you done these things before?
Yes, sir.
These kind of things you have done? Plus m, plus r, minus r?
No, sir.
No. Yeah. So when you see the reaction of benzene ring, now, so there you'll see sometimes they'll give meta substituted product, and sometimes they'll give ortho and para substituted product. So what is the condition for that? That we understand here only. If an electron withdrawing group is attached, then meta position is relatively electron rich, and hence the electrophile will get attached at meta position. Right? Because the ortho and para positions are electron deficient. So that position won't attract any electrophile, but the electrophile will get attached at meta position. So this is the reason we have for all this. Understood? Plus r, plus m, minus m. No doubt, right?
No, sir.
Okay. Hyperconjugation is not that important. Okay. One example just I will tell you. Okay. For hyperconjugation, write on the heading hyperconjugation. So it's a small thing. 2 examples we'll see and we'll finish this. You know what is alpha hydrogen? Suppose if I write this, first of all, this hyperconjugation is possible in alkene, alkyne. It is possible with carbocation. We'll discuss only carbocation to make you understand. And it is possible in free radical also. So what is required here for you, that only we'll discuss. So for carbocation, you see, we must need alpha hydrogen, H, CH2 plus. Now the alpha carbon is the carbon which is adjacent to the positive charged carbon atom. Means this carbon you see, this carbon is the adjacent carbon of this positive charged carbon atom. So this is alpha carbon. Okay, we write it as alpha carbon. And all those hydrogen which are attached to the alpha carbon are called alpha hydrogen. Alpha hydrogen. Clear? So for hyperconjugation, the necessary thing is alpha hydrogen you must have. Right? Alpha hydrogen we must have. That is the condition of hyperconjugation. The structure that we draw here, you see this sigma bond comes over here and it forms something like this. This is not that important, just you try to understand one thing here. This H plus will be present as it is. Okay, even we can draw such a structures when this sigma bond comes over here. So we'll get something like this, which is a similar structure actually. Double bond CH2. And one more we can draw, which is H plus CH, double bond CH2. So with all these 3 hydrogens, we can draw 3 hyperconjugative structures. Okay. And H plus won't go anywhere. It will present there only like this. without any bond, it will present over there. Since this H plus present there without any bond, so hyperconjugation, we also call it as no bond resonance. No bond resonance. Right, so this is it. So basically, for hyperconjugation, you require alpha hydrogen. As the number of alpha hydrogen increases, number of hyperconjugated HC structure increases, and hence stability increases. This is the thing we have for hyperconjugation. Understood?
Yes, sir.
Just you need to check alpha hydrogen, that is it. Is it clear? Now, one kind of question they may ask you, then in which of these molecules will have more hyperconjugation? For example, tell me the order here. We have CH3, CH2 plus. We have CH3, CCH3, H plus. And then CH3, CCH3, CH3 plus. Which one shows maximum hyperconjugation? You can write down the order, increasing order of A, B, and C. You can write down in your chat box, increasing order of A, B, and C. Anyone, guys? What you need to check? Tell me. What you need to check? The number of alpha hydrogen. Could you tell me how many alpha hydrogen we have here? Number of alpha hydrogen?
Three.
Yeah, right. Huh? 3. Number of alpha hydrogen here? Positive charge I missed. Number of alpha hydrogen here?
6.
6. Number of alpha hydrogen here?
9.
9. See, you don't have to do anything. You just have to check how many carbon atoms are attached with a positive charge carbon. So only 1, 3 hydrogen. We have this carbon and this carbon, 6 hydrogen. This carbon, this carbon, this carbon. So we have 9 hydrogen here. So obviously the tendency for hyperconjugation is maximum in C and minimum in A. This is the order we have. Got it?
Yes, sir.
But I don't think this will be useful to that extent. Resonance is very important for entire organic chemistry. You must keep that in mind. That is very important. Now, when you look at this structure, this is 1 degree carbocation, right? This is 2 degree carbocation and this is 3 degree carbocation. So which one is more stable? Stability order is also this. More I effect, no? Plus I.
C.
2 plus I and 1 plus I. So 3 is the most stable. You can explain the stability of carbocation with I effect or hyperconjugation. Maximum hyperconjugation, maximum will be the stability. Least hyperconjugation, least will be the stability. Same thing. Now you tell me, we have 10 minutes left, okay? And I'm not going to teach you anything now since it's the first class. So I want you to talk now. Any specific doubt, if you have, you can ask me, or whatever I have done today. In that also, if you have any doubt, you can ask me in these 10 minutes. Because it's the first session, I know there are a few things that you must be, you must felt difficult. Okay. So, and it happens like in organic chemistry, first session, all these things, if you see, you'll feel a little bit of difficulty. However, the thing is not that difficult. It's just required some practice. That is it. Okay. So any specific doubt you have, whatever I have discussed, anything you did not understand, any confusion, please go on and ask me. Swarup, are you there? Swarup. Swarup is, yes, it's there. Any doubts, Swarup, you have? Did you understand all the concept taught? Or little bit of confusion you have? Like, frankly, I want to know. Then only I can tell you some way so that you can improve things. All of you guys, if you have any confusion, like suppose 60% you understood, right? So what to do to get the other 40%? Okay, that we have to understand. All of you are in Hassan right now, right?
Yes, sir.
Yes, sir.
How is the situation there, the lockdown thing?
It's full of.
Everything is shut down completely.
Yes, sir.
You're not
Yes, sir.
going out
No, sir.
No, sir.
since how many days?
Till April 14.
April was not
14.
13.
14.
Your voice is breaking. Acha, everything is shut down.
Till
So it's
18.
18, right? 1-8. Whatever, 10-15 days, I think it is. Acha, April 14. Till April, that is no, like since how many days you did not go out? That's what I'm asking. Till April 14, I know this. 21 days, the lockdown period, right? See, I am here in Bangalore and I am,
Sir,
here
sir
at
from
my
21st March.
21st March. Okay, so I am here at my place from the last almost 3 weeks, you can say. 22 days I did not go out. It's very disturbing actually.
Yes, sir.
Okay, so the same thing I think you must also like feeling the same thing. It's to be there at that same place from the past 20-25 days. Yeah, so it's disturbing. So that's the point is a good time. Yeah, you can read not only academic books, other stuffs also you can do. Whatever you like, you can do. Don't use TikTok and all. I think that won't help in your exam. Okay, I see like many students nowadays, they have free time. They are not going out, so they are using all these things, TikTok and other things. So I was looking at one, research in these days, the past 1 month. The number of users, TikTok users, increased a lot nowadays. So that won't help. Don't do all those things. So anyways, guys, any specific doubts regarding this resonance hyperconjugation, let it be. Any other things, if you have any doubt, please let me know. You can ask anything in chemistry. Like I discussed hybridization also, right? Hybridization, have you seen those kind of concepts, how to find out hybridization? Divided by 8, find out steric number, and then you can find out that. Have you done those kind of stuffs? How many of you are looking for this exam, KCET? You can type in there. Okay, Darshan, Okay. So you are mainly looking for, okay, Kirtana, Darshan. So how many of you are looking for only PUC, the board exam? Only board exam. All of you are looking for board exams, I guess. Mostly all of you. Darshan and Kirtana, you two are interested. Fine. So little bit of for KCET, for competitive thing. Okay. So for competitive exams like KCET and all, little bit of extra stuff you should know, right? Okay, I got this, Suchit, Kushi, all those. Okay. So some extra stuff you should know. You should know a little bit of, okay, Kushi, KCET. Yes, Smriti, correct. So how to prepare for KBPY? Please don't. Okay, fine. KBPY is you are going to have this exam in this thing, October of this year. Okay, October. And they'll ask the entire thing, entire portion of 12th grade, which is mainly organic chemistry. Okay. So for preparation, there's a book in the market, okay, for KBPY. You should have that book. Okay, they have given all possible, all questions which has been asked in KBPY. Okay, they ask conceptual questions. You cannot mug up things in KBPY. I'm not, I don't have any intention of get or make you scared of these exams and all. The exam is not that tough, okay, but it is conceptual based. They ask conceptual questions. So you should be very clear with your concepts. Okay, there are many things to discuss in this. Okay, but I will suggest what there's a book in the, right now it's completely locked down, so you won't get it. Book of KBPI is available from Career Point. You know Career Point? Career Point is a coaching institute in Kota, Rajasthan for JEE NEET and all. Okay, so there's a book of Career Point especially for KBPY available on Amazon, I guess. Okay, so let this thing get over, the lockdown period, then you search for this, you will get this book. Keep that book and solve those questions. Topic wise questions is given into that. Okay, so that will give you an idea. So we'll discuss all these things. It's not like 2-3 minutes of thing that we can say, but one reference book you must have. KCET and all, like I said, for all competitive exam, this kind of thing, like I said, resonance, hyperconjugation, how to compare stability and all, this kind of comparison you should know for any competitive exam. Okay, any other thing, guys? What should we start next class? Please suggest me. What should we start next class? Chemical kinetics. Tell me fast, guys. Like whatever you say, like whatever majority will say, right? I can start any chapter. It's not no big deal for me. I'm waiting for your response, guys. Please. Again, I'm telling you, if you do not, organic compounds naming, nomenclature you meant. Nomenclature you said? IUPAC nomenclature? Okay. Any other suggestion, guys? Please do it fast. Haloalkanes, haloanes. Okay. Haloalkanes, haloanes. Chemical kinetics. They have started chemical kinetics in your college?
No, sir.
No, sir.
Okay. Fine. Okay, fine, guys. So, are you all okay with chemical kinetics? Because I can see most of you are, you want chemical kinetics to start with. All of you are okay with it? Fine. Okay, fine. So we'll just no. Yeah, fine. I got it. So next class we'll start chemical kinetics. It's a very interesting chapter, guys. Mathematical chapter actually of physical chemistry, chemical kinetics. You should have a little bit of knowledge of differentiation and integration to understand this. Very important, interesting chapter. Numerical questions are there that we'll understand. Okay. So next class we'll start chemical kinetics. What I'll suggest you, whatever we have discussed today, hybridization, resonance, hyperconjugation, and eye effect, you must revise it. It is very important, okay, for your entire organic chemistry. Okay. Fine. I think we are done for today. Okay. See you in the next class. Thank you so much, guys.
Thank you, sir.
Thank you. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye.
What line?